Okay, we're going to look at perpendicular bisectors. And each of these words really state exactly what we're doing. First of all, perpendicular means we're talking about two lines that when they cross each other, they create a right angle, right? And that's why this is also known as sometimes known as a right bisector, because it creates a right angle when it crosses it. To bisect something, like a bicycle, means to cut it in half. So if we're talking about a line, and I'm going to eyeball this, but if this is an endpoint, or a line segment I should say, then this, if this is the middle, this is where you would bisect the line. You cut it in half, and both of those distances are the same. Okay, so all we've been given is two coordinates, coordinate A and B, and we're told that we need to find the equation of the line that is a perpendicular bisector. Okay, an equation of a line reads y equals mx plus b. So the two variables that we really need to solve for are our m and our b variable. Okay, and in other words, m is our slope. Oops, that's not what I want to do. We need to find the slope between these two lines, and then from there we'll take one of the coordinates and plug it in for y and x. I'll quickly give you a look at what this looks like. So I put in the two coordinates, and don't mind this equation at the bottom, but that's just showing the example of the line segment. So we need a line that's going to be a perpendicular bisector. So we're going to figure that out. We're going to put the equation in after and see if it looks like that's what's happening. Okay. So first thing we want to deal with is our m. M deals with slope. Do you remember the equation for slope?
Y equals mx plus b.
That wasn't. That's the line. Do you remember if you have, maybe this will give you a hint. If I call this x1 and this y1, and I call this x2 and y2, do you remember the equation?
It was x1 plus y1 over y1 plus y2.
Close, close. You're closer to midpoint, because I think you've been working on that.
Yeah.
y2 minus y1. So it's always the rise over the run. That's why they call it the rise over run is slope. And x2 minus x1. And it doesn't matter which one I call coordinate 1 and coordinate 2. I could switch those up. You'll still get the same answer. So let's plug our values in. Our slope m is equal to y2. Well, y2 is the value of 4. Okay, and y1 was our 8. So 4 subtract 8 divided by, and our x2 is 0. And it's going to subtract negative 2. Okay, so we're going to use this to find our slope, our rise over our run. So 4 subtract 8 is going to give us, I'll write the rest in black, negative 4. And 0 subtract negative 2 is the same as adding 2. So it's going to be just positive 2 on the bottom. Okay, so we're going to end up with m is equal to negative 4 divided by 2 is negative 2. Great. So we've just discovered m equals negative 2, that for our equation, okay, of this line between these two coordinates, so that's this one here, our slope is negative 2. And we knew that. You can see I've written it over here. Now, what's important is something, we're looking for the perpendicular bisector, not the equation or the slope of this line. So because we have this slope now, we can deduce what a perpendicular slope is. And in order to figure it out, you have to change it to the negative reciprocal. Okay? So think of it like this. Negative 2 as a fraction is negative 2 over 1. Okay? So we're going to take this number, we're going to multiply it by negative 1, no matter what number we have, and then we're going to invert the fraction. Okay? So I'm going to put the 1 on top, the 2 on the bottom, and what is a negative times negative 1? Negative times a negative is what?
Oh, sorry, negative times negative is positive.
Positive, right. So this is the important slope for our perpendicular bisector. Okay, so y will be equal to 1/2 x plus b. B is our unknown. Okay, so we figured out the slope that's perpendicular. Okay, and if we go and type it in right away, we don't know our b yet. Y equals 1 over 2 x. If you look at that, if I bring that line up, I just don't know where the y-intercept is yet, that looks pretty perpendicular. We just don't know what our b value is, our y-intercept. So we're going to go back and solve for our y-intercept. I need to find for b. So because we're looking for b, we need a x and y value. And luckily, no, actually, we haven't figured it out yet. In order to figure out where this point is, it's going to be the point that bisects, cuts in half. So in order to find the bisecting line, we need to find the midpoint. So we're now going to use midpoint formula, okay, for this a and b. If you recall midpoint, sometimes it's written like this: x midpoint and y midpoint are equal to x1 plus x2 divided by 2, y1 plus y2 divided by 2. Or some people write it like this, which is sometimes easy. The x value of the midpoint is equal to x1 plus x2 over 2. And the y value of the midpoint is equal to y1 plus y2 over 2. Okay? Do these formulas look familiar? At least this one for midpoint?
Yeah.
Yeah. Okay, so we need our two x values, and I can find those really quickly. We've already labeled them. -2 and 0. So to find our x value, we're going to take that, -2 and 0. So let's bring it down. Our x midpoint is equal to the number -2. That was one of our x's, plus 0. Okay, and we're going to put that all divided by 2. And for our y midpoint, we just got to find our y values, which is simple. We've already done that above. They're 8 and 4. Okay, so let's put, which one did we put first? We put the ones first. So we put 8 plus 4, all divided by 2. Okay, so we can solve them simultaneously. I'm just going to stop. Okay, so let's continue here. Our midpoint value of the x is -2, because -2 plus 0 is -2, over 2, which gives us -1. So our x value is -1. And our y midpoint is equal to 12 over 2, which is 6. So our y midpoint. So the midpoint coordinate is -1 and 6. Okay? So let's go back to our page. -1 and 6. And look at that. That looks exactly like the middle of that line segment, right? So we have -1 and 6. Now, we know that that point is going to be on our line for a perpendicular bisector. So that's the value. This is the x and the y value that we're going to plug into this equation that we had semi-solved for earlier. Okay, so I'm going to bring that information down again. Okay, so we had y is equal to, we figured out the slope earlier of the perpendicular line was 1/2 x plus b. We now know that this is an x value and this is a y value, so let's plug 6 in for y. So 6 equals 1/2, and our x value is -1. And now we can solve for our b because we filled in all the other unknowns. Okay, -1 times 1/2, do you know what it's going to be? -1 times that half?
-1/2.
Yeah, -1/2 plus b. When we bring -1/2 to the other side, it becomes 6 plus 1/2 is equal to b. So our b value is equal to 6 plus 1/2 is either 6.5 or 6.5. Depends if you like fractions or you like decimals. We're going to write it as 6.5 because in our formula on the other page, they'll actually read both. It doesn't really matter. So the equation of the perpendicular bisector. So we take this, y is equal to, our perpendicular slope was 1/2, and our y-intercept, or our b value, was 6.5. So plus 6.5. So let's go to the other page, and let's add 6.5, and boom, there we go. This is our perpendicular bisector. It cuts right through the line, okay? It cuts it right in the middle, and it makes a perpendicular line with what we were working with.